Okay, so now that we have taken a look at the basics, what's an argument, what's a premise, what's a conclusion, what are the indicators, how do you standardize an argument, and then we moved on to how do you recognize an argument from other kinds of passages that might seem like they're trying to be an argument but really aren't, because there's no system of inference. That puts us in Chapter 1, Section 3, which is deductive and inductive argumentation. Right, so let's get some formalities out of the way. Let's get some definitions. There are two main classes of arguments, right? And these are divided up according to the way that the person who wrote the argument wants it to be, right? It's a style of reasoning. Deduction is a style of reasoning. Induction is a style of reasoning. And whomever is making the argument decides, whether they're fully conscious of it or not, which style or class of reasoning they want to use, right? So first, a deductive argument is one in which we expect the conclusion to follow with necessity from the premises. So we expect the premises to support the conclusion in such a way that if the premises were true, the conclusion would have to be true, right? So if you assume the premises are true, then the conclusion would have to be true as well. It kind of follows like math. And in an inductive argument, that's one where we expect the conclusion to follow only probably from the premises, not with necessity like up here, but probably. Right? We expect the premises to support the conclusion in such a way that if the premises were true, the conclusion would probably be true as well, but not necessarily, as is the case up here. Right? Very often, inductive arguments are thought of as good reasons arguments. Like you got a conclusion you want to convince somebody of, and you provide them with a series of reasons why it's rational to accept that conclusion. Whereas up here, you got a conclusion you want to convince somebody of, and you provide them with a series of premises that guarantee that the conclusion would be true if the premises were true. You know, this is best understood through examples, and then you can kind of pick up the rhythm of these arguments and see the signposts of each of the arguments. Okay, so let's look at the standard forms of deductive argumentation. These are just methods that people who are trying to construct a deductive argument, they use these methods. There's argument by mathematics, argument from definition, there's categorical syllogism, there's hypothetical syllogism, and there's disjunctive syllogism. All right, so we're going to take each in turn. So now we're just looking at deductive arguments here. First, argument by mathematics or argument by math. All right, that's a deductive argument where the conclusion depends on a mathematical or geometric calculation. We make these consistently. Right? So some examples. Bob has 1,275 songs on his phone. He just downloaded 5 more. Bob now has 1,280 songs on his phone, right? It's mathematical. If there's some dude named Bob with that many songs on his phone and he downloads 5 more, if these are true, it necessarily has to be true that he now has 1,280 songs on his phone. Not probably, necessarily. Or a Hummer is bigger than a PT Cruiser, and a PT Cruiser is bigger than a Mini Cooper. Therefore, a Hummer is bigger than a Mini Cooper. So if these two premises are true, notice you don't even have to know anything about cars, right? If this thing is bigger than that thing, and that thing is bigger than the other thing, it follows that this thing is bigger than the other thing, right? Follows mathematically. Necessarily, too. Deductive. Okay, next, argument from definition. Right? That's a deductive argument where the conclusion is claimed to depend merely upon the definition of some word or phrase used in the premises. And these arguments are important very often and can be very powerful in that they help determine what something or someone is, which we argue about consistently. Thus, they can result in inclusion or exclusion from a particular group. They help us recognize that classifications change over time and are the result of cultural, social, and political forces, right? If you've ever heard somebody just say, well, first we got to define our terms, then you understand this form of argumentation. All right, let's look at some examples to flesh this out. By definition, sports require the demonstration of personal physical skill and power. Auto racing is the demonstration of mechanical strength and power. Therefore, auto racing is not a sport. Actually, I should have emphasized this differently. Let me say that again. By definition, sports require the demonstration of personal physical skill and power. Auto racing is the demonstration of mechanical strength and power. Therefore, auto racing is not a sport. People actually argue about this, people who care. They want to say auto racing isn't a sport. Well, how come? Because by definition, sports require personal skill and power, and auto racing requires mechanical strength and power. So that's why auto racing is not a sport. Now, if those two premises are true, if you assume that they're true, the conclusion follows necessarily, not probably. The conclusion would have to be true if those are true. Or, terrorism is any non-wartime act of violence undertaken for political gain. The IRA committed non-wartime acts of violence for political gain. Therefore, the IRA was a terrorist organization. So somebody's wanting to argue that the IRA was a terrorist organization. Well, how come? Let me define terrorism for you. Then let me tell you that this group fits the definition. Therefore, by necessity, you can say the IRA was a terrorist organization. Okay. Next, categorical syllogism. So the last three that we're going to look at in this group of deductive arguments are syllogisms. And a syllogism, very simply, is a deductive argument with two premises and one conclusion. So all deductive arguments, all syllogisms, that is, are deductive arguments with two premises and one conclusion, but not all deductive arguments with two premises and one conclusion are syllogisms. Let's just get into it and see how we can identify these things. Excuse me. A categorical syllogism is a deductive argument that categorizes or sorts things into specific classes, like mammals or students or countries or be it what it is, right? These are just examples. So the keywords, if you want to know whether you're looking at a categorical syllogism, look for these keywords: all, some, no. Also look for two premises and a conclusion, right? They have a rhythm. So for example, all rattlesnakes are poisonous, and some of those snakes over there are rattlesnakes. Therefore, some of those snakes over there are poisonous. Notice the all, some, and some, right? Notice also these things have patterns, these syllogisms, and categorical syllogism is one of them. You can see rattlesnakes repeated twice, poisonous repeated twice, some of those snakes and those snakes twice. But importantly, the alls and sums, right? Categorical syllogisms. If these two premises are true, the conclusion follows necessarily. The conclusion would have to be true as well. Or down here, no Brazil nuts are delicious, and some of those mixed nuts in that bowl are Brazil nuts, therefore some of those mixed nuts in that bowl are not delicious. Again, if the premises are true, the conclusion would follow necessarily. You got the no's and the sums. These are categorical syllogisms. Next, hypothetical syllogism. That's a deductive argument containing a conditional statement, which is an if-then statement, for one or more of its premises. So in other words, they involve if-then thinking, hypothetical thinking. right? So in a conditional statement, which is sometimes called a hypothetical statement as well, we can use these interchangeably. If you've got if x, then y, x, the x part, is known as the antecedent. The y part is known as the consequent. All right, so let's look at some examples. If you plan on drinking tonight, then we can't take your car. Say the if and the then. Well, you said you plan on drinking tonight, therefore we can't take your car. If these premises are true, the conclusion would follow necessarily. So what you have here is if antecedent, then consequent. Well, you got the antecedent, so you got the consequent. Hypothetical syllogism. And another, if it had been raining, then the ground would be wet. Well, notice the ground's not wet, so we can deduce that it hasn't been raining. Again, if antecedent, then consequent, not consequent, therefore not antecedent, right? Important here, if you're going to spot these, is you're looking for this if-then statement, and then you're looking for another premise that says either affirms or denies the antecedent or consequent, and your conclusion, right? And what's going to be important for right now is that you just recognize these things. And last of the deductive group is disjunctive syllogism. So that's a deductive argument in which one of the premises is an either-or statement, right? With the hypothetical, you got an if-then statement in one of the premises, or as one of the premises. For disjunctive, you've got an either-or statement. And these, when properly made, disjunctive syllogisms are essentially arguments by elimination. So the telltale statement in a disjunctive syllogism is the either-or statement, the disjunctive statement, either X or Y. So both of these the X is referred to as a disjunct, and so is the Y. X and Y are your disjuncts. So some examples. Either I left my keys in the store or I locked them in the car. Well, as it turns out, they are not in the store, so by elimination, they must be locked in the car. Assuming these two premises are true, that conclusion would have to follow. That conclusion would have to be true as well. Next, either you drank the rest of my beer or our roommate Floyd did. I know for a fact that Floyd did not drink the rest of my beer, so it must have been you. No, right? So notice, you got a disjunct here, either disjunct or disjunct. One of these two things is the case. Well, we know for sure that it's not this disjunct, so it must be the other. Classic argument by elimination, and when these come in this form, the conclusion would follow necessarily. Good. Okay. Now, standard forms of inductive argumentation, right? So we're done looking at those deductive arguments where the conclusion is meant to follow necessarily from the premises, and we're moving on to the class of arguments called inductive. And in inductive argumentation, if you remember, the conclusion is meant to follow only probably from the premises, right? Not necessarily, but probably. You got a good chance that the conclusion is going to be true if the premises are true. And so here we've got argument by prediction, argument from analogy, generalization, argument from authority, and a causal argument. So prediction. That's an inductive argument that relies upon premises that deal with some known event in the present or past in order to draw a conclusion about the future. We constantly think in all of these terms, right? I'll say more about that at the end. So examples. Every time I've come to school at 9 a.m. before, I've had trouble finding a parking space. And I'm going to school at 9 a.m. today, so I'll probably have trouble finding a parking space. So given these premises, if you just pretend for a minute that they're true, right? It's probably the case that you're going to have trouble finding a parking space, right? Is it necessarily the case? No, you could get lucky, right? But given these two reasons, it's likely the case that you're going to have trouble finding a parking space. You're making a prediction based on past events. In the winter, I always get an electrical shock when I get out of my car, and I'm about to step out of my car, so I'll probably get shocked, right? So these two could be entirely true, right? But that doesn't mean the conclusion has to logically be true. You might not get shocked this time. Maybe you touched something in the car that grounded you before you stepped out, right? So if these are true, the conclusion is likely to follow. The conclusion is probably true, but not necessarily. Okay. Argument by analogy. That's an inductive argument that relies upon similarities between two or more things or states of affairs in order to draw a conclusion. So it basically claims that if two entities have certain characteristics in common, chances are they have one or more additional characteristics in common as well. So let's look at some examples, the best way to get familiar with these. The Acme Cafe and the Zenith Grill are both vegetarian, they're both Mediterranean themed, and they both have chefs trained at the Culinary Institute of America, right? So I got these two places that share all these similarities. And I know, in addition to knowing this, I know that the Acme Cafe makes outstanding hummus, just great hummus, right? So because of everything that the Acme Cafe has in common with the Zenith, right, I conclude that, the Zenith Grill probably makes outstanding hummus as well. Right? You're comparing two or more things in order to generate the conclusion. Now, notice, both of these could be entirely true, but that doesn't mean necessarily that the Zenith Grill is going to make good hummus. But considering what they have in common, they probably do. All right? That's an argument by analogy. Next. Rats and humans have similar immune systems, and experiments have shown that rats exposed to cigarette smoke tend to develop cancer. So considering the similarity of immune systems between rats and humans, most likely humans exposed to cigarette smoke tend to develop cancer as well. So for instance, all animal experimentation in science is they're all analogical experiments, right? If you want to test a new drug you want to develop a new drug for cancer, right? You find an animal, which unfortunately, you find an animal that has a similar immune system to us, right? Like a rat, and that's simply the case, right? And you test the drug out on the rat, and whatever conclusions you come to there, you say, well, considering how similar our immune systems are, these things are probably going to happen to humans as well. So it's a very common type of argument we make. Next, generalization. That's an inductive argument that proceeds from knowledge about a selected sample of a group to some claim about each member of the whole group. Right? Do this consistently as well. Let's look at some examples. So the 3 sandwiches I have eaten from Mona Lisa, a restaurant, have been delicious. So most likely all of their sandwiches are delicious, right? Even if this is true, the conclusion doesn't follow necessarily, but probably. I've had 3 sandwiches, so most likely all of their sandwiches are delicious. Now keep in mind also that we're not evaluating these arguments yet. We're just learning to spot them. Right? So what's important here is that you see that somebody's generating a conclusion. Hey, that place just simply has great sandwiches, right? How do you know? Well, I've had 3 from there, and they've been just great. So you are basing your conclusion on a sample of their sandwiches, right? Another example. 4 out of 5 dentists polled say that Crest toothpaste is the best for preventing cavities. So most likely the majority of all dentists say that Crest is the best for this as well. Right? That's really what they're trying to convince you of. It's most likely the case that the majority of all dentists think Crest is the best. How do you know? Because we took a poll and 4 out of 5 said it was the best. So if you extend this to the entire population of dentists, this conclusion is probably true as well. Doesn't follow necessarily, but it's likely that this is true. Argument from authority. That's an inductive argument where the conclusion rests on the acceptance of some statement made by a presumed authority or witness or expert. We often use these forms of argument, right? Examples. The Surgeon General has declared that smoking is bad for your health, so you probably ought to stop. You want to convince somebody, hey, you got to stop smoking, man. Well, how come? Because the Surgeon General said it's bad for your health. And if anybody's going to know, this person will know. That is employing argument by authority, right? Or the National Weather Service has issued a severe winter storm warning for the Southeast, so you ought to stock up on emergency supplies. Hey, have you gotten your emergency supplies for that storm yet? No, man, you really ought to. Well, how come? Because this authority has issued a severe winter storm warning. They know. They're the experts. So you ought to take their advice. Good? Okay. And then finally, causal arguments. So that's an inductive argument that proceeds from knowledge of a cause to a conclusion about an effect, or the reverse, a knowledge of an effect to a conclusion about a cause. Very important form of art. All of these arguments, both deductive and inductive, are essentially the way that we make sense of the world, right? And this is a big one. So examples. I accidentally left the milk in the car today for 8 hours, and it happened to be 90 degrees today, so most likely the milk will be bad. So if these two are true, then this conclusion would probably follow, right? It doesn't necessarily follow. I mean, something else could have happened, right? Somebody could have gone into your car and taken out the milk. So although this is likely, it doesn't follow necessarily. But more specifically, this one is moving from cause to effect. You're saying, uh-oh, I left the milk and it was really hot. That's the cause. What's the effect going to be? Ooh, the milk's going to be bad. That's moving from cause to effect. Now, this one. When I went out to my car first thing this morning, my front left tire was flat. And it was perfectly fine on the drive home last night. So I probably ran over something sharp right before I got home, right? This is moving from effect to cause. You go outside, oh man, what happened to my tire? It was just fine on the drive home last night. You know what? I probably ran over something sharp right before I got home. That's moving from noticing the effect and speculating in the conclusion about the cause. Right? But again, notice the inductivity here. Even if these two are true, that doesn't have to be true. Somebody could have came and slashed your tire, for instance. But considering your circumstances, it's likely that this is true. Okay, now before we close this down, I thought we'd just go through some quick examples with answers. Okay, so we're mixing. I'm just going to give you a example slide followed by answer slides. So keep in mind the 10 argument forms. So deductive we had 5, inductive we had 5. These are all going to be mixed up, and we'll take a look. Okay, ready? Either Colonel Mustard or Professor Plum killed Mrs. White. Since we know for certain that Colonel Mustard couldn't have killed Mrs. White, must have been Professor Plum. Deductive, and that's a disjunctive syllogism. And how do we know? Because of that either or claim. It was an argument by elimination. Next, I've never met a golden retriever with a nasty disposition. I bet there just aren't any. Answer, that was inductive, and it was a generalization. Somebody is claiming essentially that there aren't any golden retrievers who are nasty, and they're basing that conclusion on the fact that every experience they've had. with golden retrievers. They've been nice dogs, right? You're drawing a conclusion from a sample. Example, it must have been the pizza that made me sick. I was just fine before I ate it. That's inductive, and it's causal. Your conclusion is that, ooh, it's the pizza that made me sick. Well, how do you know? I was fine before I ate that, so it must be the pizza that caused the sickness. Example, all mammals are warm-blooded animals, and all whales are mammals, therefore all whales are warm-blooded animals. Now you hear that rhythm, right? And then the alls, all, and the mammals and whales, right? That's a giveaway. That's deductive. It's a categorical syllogism. Example, Max always ditches his friends when he has a new girlfriend. He'll probably do the same thing this time around. So here's your conclusion. How do you know this? Because he always ditches his friends when he has a new girlfriend. That is inductive. It's a prediction. You're making a prediction about the future based upon your knowledge of the past. If it rains all night, then the softball game will be canceled. And the softball game was not canceled, so it must not have rained all night. Notice the if and the then, two premises, one conclusion, a little bit of rhythm in there. That tells you you've got a deductive argument, and it's a hypothetical syllogism with the if-then stuff. The figure he drew only has 3 sides, so it follows that it isn't a square. So just reading this argument, you can tell it's deductive. If it's the case that he drew a 3-sided figure, it for sure and necessarily is the case that it isn't a square, right? But this could be definition or math, right? There's some crossover in this example, which is perfectly fine. Bob stayed up partying all night. He probably won't make it to the gym at 6 a.m. That's inductive, causal. So you're arguing that Bob's not going to be here at 6 a.m. He's not going to show up, man. At 6 o'clock, he will not be here. How do you know? Because he stayed up partying all last night, right? You know that situation is going to cause Bob to not feel fit enough to be at the gym at 6 a.m. When blue jays are breeding, they become aggressive. Scrub jays are very similar to blue jays, so they will probably become aggressive when they're breeding as well. So here you're trying to conclude that these scrub jays are going to be aggressive when they're breeding. Well, how do you know that? Because I know this about the blue jays, and they're very similar to the scrub jays, so I'm going to generate this conclusion. Well, we know it's inductive because the conclusion would not follow necessarily, even if the premises are true. It would follow likely or probably. And it's an analogy where you're comparing different things in order to generate the conclusion. Since all grapes are fruit and some grapes are purple, it follows that some fruit is purple. Now notice you got that rhythm going, purple, purple, grapes, grapes, fruit, fruit, all, some, deductive, categorical syllogism. She's not in Cabo, and she's either there or in Vegas, so she must be in Vegas. Notice the either or. Notice you got a little bit of repetition. Right? Seems like something's being eliminated here as a choice. So that's deductive, disjunctive syllogism. It must be the case that 60% of the students at that school are Democrats, since 60% of the students in one of those classes at that school are Democrats. So you're trying to conclude this, that 60% of the students in the entire school are Democrats based on a poll you took, where 60% of the students in one of the classes at that school are Democrats. That's inductive and generalization. He must not have brought any dip, because if he brought dip, then she brought chips, and she didn't bring any chips. Notice you've got the conclusion first, you got the if-then claim, and then it's saying no to the second part of the if-then claim. That is deductive hypothetical syllogism. Like a watch, the universe is a complex system. We wouldn't think that a watch would come about by accident, hence we shouldn't think that the universe could come about by accident. Here's your conclusion, right? You're making a comparison between a watch and the universe. We got inductive analogy. She can never get to sleep at night. Perhaps it's the 8 Red Bulls she drinks during the day. This is your conclusion. Well, I'm sorry. This is the conclusion. She can never get to sleep at night. Well, why? Because she drinks 8 Red Bulls during the day. So what could be causing this circumstance? That's inductive and causal. And finally, she's going to need cataract surgery soon. Her ophthalmologist told her that her vision is going to get worse and worse by the day. So here's your conclusion. Well, how do you know this is true? How do you know she's going to need cataract surgery soon? Because her ophthalmologist told her, an authority told her. So that is inductive authority. Okay, everybody, that's it for 1.3 and recognizing these different argument forms.